Hi, 7th grade. Today we're working on our last section of the week, and that is lesson 4.4, day 1. We're going to spend 2 days on this because this is spheres and cones. So we're going to be working on page 77 in your book, and we're going to be doing just the volume of spheres today. We'll save cones for next time. Your gotta check is going to be on page 79, and on page 79 we're going to be doing C, and it's a whole chart, but we're only going to be doing the sphere with radius 3. And then your homework is going to be the volume of spheres worksheet, and our bell ringer is going to be page 68, number 50. All right, let's get started. So when we think about a sphere is typically what we think of as a shape like a ball. The earth is a sphere, a tennis ball or a basketball is a sphere. So a sphere, typically when we draw it, a lot of times we'll show the radius, and then usually it will kind of show like a little curvature, so you kind of get the idea, okay, that it's a sphere. In this case, the radius extends in 3 dimensions all around the circle, so from a single point. So instead of just extending in 2 dimensions, it's going to extend in all dimensions from a single point. So that's what gives us a sphere. Volume of sphere is kind of a neat formula. So a volume of a sphere is 4/3 times pi r cubed. And this is important, it's r cubed, because as you can guess, we're talking about 3-dimensional space, so this is going to be cubic units. So as long as we know the radius of the sphere, we can find the volume using this formula. All right, let's try a quick example. So I'm going to use an example, and I'm going to find the volume of a sphere with radius 2. So I'm going to say that our radius equals 2, and I'll just kind of draw a very quick picture, just so you can get an idea that this is a sphere with radius 2. Maybe we'll make it centimeters. I love centimeters. Okay, so let's plug this into our formula. So if we look at our formula, I would plug this in. So my volume is 4/3 times pi times the radius cubed. And in this case, my radius was 2, so I would just plug my 2 in there, okay? This is going to give me kind of an interesting fraction, and that's okay. So if I look at this, 2 cubed is 8. So that would be 2 times 2 times 2. So 2 cubed is 8, and 8 times 4 is 32. So I end up with this kind of interesting fraction, 32/3 pi, okay? This would be our exact answer, and we would be using cubic centimeters, okay? But this is kind of ugly looking, so as usual, we can get an approximation by multiplying by pi. So I'll take 32/3 times 3.14, and that gives me an approximation for the volume. And as I take a look, my volume is around 33.5, so I'm just going to abbreviate it there, and again, this is cubic centimeters, okay? Both of these guys are correct, the exact and of course the approximate answer. All right, I feel like you guys are ready to try your gotta check. So your gotta check is page 79, and we're doing C, and in C, we're doing the sphere that has the radius this time of 3. Okay, pause the video, come back when you're ready, and we'll see how you did. All right, let's plug this into our volume formula. So our volume formula was 4/3 pi times 3 cubed. If I finish that out, okay, what ends up happening is I end up getting 3 cubed is 27, and times 4/3, that would be 36. So I now have 36 pi, and I think our units were centimeters, so we'll use centimeters cubed. But as usual, I probably want an approximation. So 36 pi, if I multiply 36 times 3.14, I get an approximate answer of around 113 0.04 cubic units. So again, I've got my exact answer here. I've got my approximate answer here. And wait, it wasn't cubic units, it was cubic centimeters. All right, time for your homework. So your homework today is to try the volume of spheres worksheet and bell ringer page 68, number 50. All right, bye 7th grade. We'll see you later.